Chapter 9.3, Geometric Sequences in Series. So we're going to recognize and write and find the nth terms of geometric sequences, find the sum of finite and infinite geometric series, and then use geometric sequences to model and solve real-life problems. So the definition of geometric sequences is that a sequence is geometric when the ratios of consecutive terms are the same. So looking at this sequence here, it's geometric when there is a number such that a2 over a1 equals a3 over a2 equals a4 over a3 and so forth. They have the same common ratio. So here's the nth term of a geometric sequence. So here's the rule or the formula here. And so you have a to the n equals the first term times a ratio raised to the n minus 1. R is the common ratio of consecutive terms of the sequence. So every geometric sequence can be written in this form below. Then when you know the nth term of a geometric sequence, you can multiply by r to find the n plus 1th term. So let's find a term of a geometric sequence. Find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.05. So we're just going to use the formula that we were given. So we want to identify what we know. The first term is 20 and our ratio is 1.05. So using the rule a sub n equals 20, the first term, times the ratio, 1.05 raised to the n minus 1. We want to find the 15th term, so therefore we are trying to find 15 minus 1, which is 14. So a sub n equals 20 times 1.05 raised to the 14th. And then when you plug it in your calculator, depending on which calculator you use, but you would have to find the exponent first and then multiply by 20, or in some calculators you could just plug it in directly as you see it. And then when you do that, you will get approximately 39.60 or 39.60. So letter B, try letter B out. So if you tried this out, you should have gotten 104.02. Now let's write the nth term of a geometric sequence. Find a formula for the nth term of each geometric sequence. So we know in letter A that the first term is 5. Then we want to find the common ratio. So that's 15 over 5, which is 3. And then if you checked 45 over 5, that is still also 3. So then we write the formula. Remember the formula is a sub n equals a sub 1 r to the n minus 1. So then you write a sub n equals 5 times 3 raised to the n minus 1. Then what is the 12th term of the sequence? So you plug in a sub 12. So 5 times 3 to the 12 minus 1. 5 times 3 raised to the 11th. And you find that it grows very, very quickly. And when you find the answer, after plugging in your calculator, you would get 885,735. So try out letter B on the right. So if you tried this out, you should have gotten the rule or the formula a sub n equals 4 times 5 raised to the n minus 1. Then the 12th term of the sequence is 195,312,500. So let's find a term of a geometric sequence. So the fourth term of a geometric sequence is 125, and the 10th term is 125 over 64. We want to find the 14th term and assume that the terms of the sequence are positive. So we know, we know a sub 10 is 125 over 64. And the fourth term, a sub 4, is 125. So what we can do is we will try, we know a sub 10 and then a sub 4, and then that ratio, what we're going to do with that ratio is we're going to subtract the 10 minus 4. Okay, so n minus 4 there. Then we find that that becomes a sub 10 equals a sub 4 of r to the 6th power. So we know what a sub 10 is. A sub 10 is 125 over 64 equals a sub 4, which is 125 r to the 6th. So now let's solve for r. So let's divide by 125, or it's 1 over 125 here. So that cancels the 125. So we have 1 over 64 equals r to the 6th. Then we take the 6th root of both sides. And so we find that r equals 1/2. Then to solve, we need to continue solving. And so let's use a sub 14, because we're trying to find the 14th term. And then, so that's going to be a sub 10, r to the 14 minus 10. So a sub 14, a sub 10 is 125 over 64 times the common ratio of 1/2, and then 14 minus 10 is to the 4th power. So we keep on evaluating, so 125 over 64 times 1 to the 2 to the 4th power is 16. And then so you find that a sub 14 is going to be 125 over 1024. Okay, so letter B, try out this, finding the second term, or we're going to find the 8th term, I apologize, and then try using this method here. So trying this out, you should have gotten a sub 8 equals 2,187 over 32, and then going back, the ratio is 3/2 here.